Hi everyone, welcome to my channel, Tutorly Test Prep. Today we'll be going over 7 hard problems for the March 2024 DSAT. Problem Sette number 5. The goal of the Problem Sette series is to provide an original worksheet of challenging problems right before the test date. This gives students the opportunity to push themselves while also reviewing a variety of topics. Please download the worksheet for free using the link in the description and attempt the problems yourself before watching this video. Let's get started. Okay, for question 1, this one, as you can see, is on box plots. I already went over box plots in my Ottocento number 9 on basic statistics, so please watch that if you haven't already. I'll link it in a card, but I'll also very briefly go over it here. So pretty much the vast majority of what you need to know is that this line here tells you the median, this line here tells you the min, and this line here tells you the max. And range, as always, but especially in box plot questions, is max minus min. So the vast majority of the time you see questions like this, they want you to find the range or the median. So let's see here. This question says we're going to combine these two data sets into one data set. And we want to know the range of the combined data set. So we don't actually know a lot about what each percentile for the combined data set is going to be, but we can look and see that quickly that for the green, the data set A, this is the min, this is the max, and this is the median. And for data set B, this is the min, this is the max, and this is the median. We won't be able to determine what the median is, but we can determine the range by looking for the rightmost data value and the leftmost data value. So as you can see, if I look over on the right side of this graph, the rightmost data point is this whisker from the top one, which is the max. And I know this picture isn't great, guys, but I believe that's 29. And the leftmost data value, if we combine them together, is going to be the whisker from dataset B, the red one. So that would be this guy here, which is 3. So the range of the combined dataset will be max minus min. So 29 minus 3. Which is 26, and that is our answer. Let's move on to question 2. But first, let's hear a quick word about today's sponsor, No BS SAT Prep. No BS SAT Prep is a comprehensive, on-demand SAT prep platform designed by experts that have been tutoring for the better part of a decade. The program includes over 200 videos that cover all the content tested on the digital SAT and over 1,700 practice questions, all neatly organized by topic. To top it all off, the platform has many realistic Blue Book app features built in, such as highlighting, crossing out, and even Desmos integration. I've personally been using Jackie and Josh's materials for years with my students and have seen the score improvements they yield firsthand. If you want to improve your DSAT score, stop by No BS SAT Prep and purchase a subscription today, or sign up for a 48-hour free trial. You can use code KYLE for 10% off all plans now until May 1st. Link in the description. Now, back to the video. Okay, so I've definitely done these by hand in some of my larger videos before. It doesn't have a designated video yet, so I figured it would be great to put in the Problem Sette series. So basically, guys, what we're going to do is we're going to do some algebra here to get this guy to look exactly like the equation of a circle, which I just wrote. You have to have that equation memorized. They don't give it to you on the formula sheet. Okay, so first thing we're going to do is we're going to check to see if the x squared and the y squared have a 1 in front of them. They do not. They have a 3. So completing the square is going to be way more difficult if we don't get rid of that 3. So what we're going to do is we're going to divide everything in the equation by 3. So we get x squared plus 18 divided by 3, 6x plus y squared minus 6 divided by 3 is 2, so 2y. 15 divided by 3 is 5 minus 5. 0 divided by 3 is just 0. Great, so that was the first step, was make sure there's a 1 in front of the x squared and the y squared. Second step is we're going to organize the equation. So just like this, we're going to put the x's, leave some space. We're going to put the y's in order, just like a quadratic, leave some space. And then we are going to, if it's not already, move the constant to the other side. So to do that, I am going to add 5 to both sides. So we get a 5 on the right side. So it should look something like this, and you see there's these kind of blanks here, and we are going to fill in these blanks by adding b over 2 squared, b being the coefficient of the x or y term, just like in a quadratic. So you see b for the x's is 6, and b for the y's is -2. So let's go over to Desmos, and I can just show you guys the calculation. So I'm going to do 6 over 2, b over 2 squared. So 6 over 2 squared, and I get 9. And now I'm going to do -2 over 2 in parentheses squared, and I get 1. So I'm going to come over here, and I'm going to put plus 9, add it to both sides, not just there. You have to put it to both sides. And then for the y's, I'm going to do plus 1 to both. Plus 1. This is how everyone gets these wrong, guys. They forget to do it to both sides. That is really important. Okay, I think we're good with that for now. Let's go back to the whiteboard. Okay, now that we have these nice quadratics, I can put some parentheses around them. And we're going to factor, and if we did it right, they should come out to perfect squares. So what adds to 6 and multiplies to 9? Well, that's 3. What adds to -2 and multiplies to 1? Well, that's -1 times -1, right? So this is x plus 3 squared plus x plus 3 times x plus 3, which is just x plus 3 squared. And this is y minus 1 times y minus 1, which is just y minus 1 squared. And then let's see, 5 plus 9 plus 1 is 15. So all of a sudden, this looks a lot more like the equation above. So we're going to quickly find the center and the radius. So the center, we circle these numbers and change the sign because there's minuses in front of them in the equation. So the center is -3, 1. And the radius, remember guys, that number on the right side is r squared. So you have to take the square root. So we're going to take the square root, and that will just be square root of 15. And if we could simplify that, we would simplify that, but there are no perfect squares, I don't think, that go into 15, right? Like 4, 9, none of those go into 15. So that would probably be it for lots of questions. However, you'll notice they'll make these questions. So even if you know how to do this on Desmos, which we'll go over in a second, you still need to know how to be able to solve the follow-up question. If you did all that work and you don't know how to solve the follow-up question, you can't get the answer right. So even if you use that first part to do Desmos, you still need to understand what it's asking you here. So it says the circle is inscribed in a square. What is the area of the square? Okay, so the circle is inscribed in a square. So the circle is inscribed in a square. So it's like inside it. So kind of like this. So you'll notice if I draw a radius, or a diameter rather, up and down, or left and right, that will give me the side length of the square, which is what we want. So if the radius is root 15, then that diameter is 2 root 15 times 2, right? Because it's double. So the side length of the square is 2 root 15 all around. Now to find the area of the square, we just use the formula area equals s squared. So area equals 2 root 15 squared. And let's see what that is. I know what it is, but it's still helpful to go over how to type. So parenthesis 2 sqrt 15 tab parenthesis squared. And we get 60, and I believe 60 is the answer. So the area of the square is 60. So when you see a circle inscribed in a square, often the strategy is to draw a diameter straight up and down or straight left and right to figure something out about the picture. Just remember that number we got looking at the equation of the circle was the radius, not the diameter. So to get the diameter, you got to double it. All right, let's move on to question 3. Okay, everyone, for question 3, this is something I haven't included in this series yet, so I really wanted to. So this is, and it's something that tons of people forget because it's something you learn about in middle school. And what they'll do is they'll blend these ratios questions with harder, more algebraic questions. And because you haven't done it since you were in middle school, it's just really hard, right, and disorienting. So for ratios, I have gone over this in other videos before, just very briefly. A to B is the same as A colon B, which is the same as A over B. So all of these are interchangeable. So what we're going to do is we almost always, to solve questions, we use fractions. I mean, to me, that's what we're probably most comfortable with, right? Because you don't use these 2 and colon a lot. But you will see 2 and colon in the questions and answers. So you have to kind of pay very close attention to the order and make sure that what's supposed to go on top goes on top and what's supposed to go on the bottom goes on the bottom. So let's read this question, this really long word problem. So it tells us we have a table. The screens are in thousands. It's all ratios. I don't need to change it to thousands anyway because the thousands would just cancel out, right? Because that's how fractions work. If you put zeros on the top and zeros on the bottom, they will cancel out. So it says a movie theater chain is considered a big chain if it has more than 6,000 screens. Okay, and it says the missing one, Wanda, is a smaller chain. Okay, so let's pick out the bigger screens. The big chains. So bigger than 6,000. So okay. So not Cinemark, that's not bigger than 6,000, that's 6,000. Regal has 7,000, that's bigger. So that's a big chain. Let's see what else. Cineworld has bigger than 6,000, so that's a big chain. And then AMC has bigger than 6,000 screens, so that's also a big chain. I believe that is it. So when it says more than, it has to be greater than. It can't be equal to. So we're not going to count Cinemark. Okay, so now this is really important. Do you see it says the ratio of big chain screens to all screens is K to 5. So big to all. So I'm going to do big over all. And see how I write it in words to the left so that I'm way less likely to make a mistake? So let's do that. And then the same order, K to 5, K over 5. So many people would mix and match those. And now we're going to do another fraction, and that also has to be, the whole way through, has to be big over all. Okay, so I look at the big that we highlighted, 11, 7, and 9. Okay, that's 27. And then all is just all of them in the table. So we're going to add all those up. 11 plus 5 plus 6 plus 7 plus 3 plus 9 plus 2. So that's 43. And there's an x. So it's going to be 43 plus x. 43 plus x. on the bottom. Now this question is asking us to get k in terms of x. So look at what's before the in terms of. You want to get k by itself, the thing that comes before the in terms of. So we now have this nice equation here that we can cross multiply. So I'm going to do k times 43 plus x is equal to 27 times 5. What is that? 135. Okay, and now we're going to get the k by itself. Well, I'm not going to distribute because that would then just mix the k with the x, which we don't want. What I am going to do, though, is to get this k by itself is I'm going to divide by the thing that's multiplying. It's getting multiplied by, which is 43 plus x. We're going to divide both sides by 43 plus x. And I get k is equal to 135 over 43 plus x. And let's look at the answer choices. That is answer choice A, which I believe is the correct answer. So there's a lot of really important things going on in this question, guys. You need to know how to do a story problem. You need to know how to read a table. You need to know how to write ratios. And at the very end, there were some literal equations involved. So this was a really loaded question. You probably could surmise like a guess for x and then kind of because it's smaller, right? You know it's going to be 6 or smaller, so between 0 to 6. You could probably guess, say like, oh, x is 4, and then plug them into the answer choices, and you could cross out some of them, but you wouldn't be able to cross out all of them. Also, right, if this weren't a literal equation, keep in mind that this could be a student-produced response, and like if I gave you more information and said, what is x, and x was like 4 or something, you wouldn't have been able to use the answer choices to guide you because there wouldn't be any. Okay, great. Let's move on to the next question. All right, so for question 4, we've done these before in other videos, but again, I haven't really given this any spotlight in this series yet. So you can kind of see by looking at the question that it wants us to combine the two fractions. So what we're going to do is we're going to get a common denominator. I'm not going to go over this in that much detail. I really hope that if you want to learn more about this, you look up on YouTube like Algebra 2, least common denominator, rational expressions, and you can see some trickier ones. But the vast majority of time on the SAT, the denominators, in this case 2x plus 7 and 5, they don't really have any anything in common. So 2x plus 7, you can't really factor at all. And then 5 is prime. So they don't really have any common factors at all. So in that case, the LCD is pretty much just those two things multiplied together. So in this case, the LCD is just going to be 2x plus 7 times 5. So what we're going to do is we're going to multiply the top and bottom of each fraction by the one that is missing. So 2x plus 7, that left one is missing 5. And the right one is missing 2x plus 7. So we're going to multiply the top and bottom by 2x plus 7. So 5 times 3 is 15. 5 times 2x plus 7 is 10x plus 35. You can kind of see where that's coming from in the answer choices in the question now. We're going to do minus. Okay, 5 times 2x plus 7, that's 10x plus 35 once again. And this is going to be a little bit of work, 4x minus 6 times 2x plus 7. Why don't I do that kind of off to the side up here. So first, 4x times 2x, that's 8x squared. Outer, 4x times 7, that's 28x. Inner, negative 6 times 12, minus 12x. Negative 6 times 7, that's negative 42. And if we combine the like terms, again, guys, looking up here, Not worried about the minus sign yet. We'll take care of that in a minute. So 8x squared. We have to come in like terms. So 8x squared, 28 minus 12 is 16. So plus 16x minus 42. And we're going to put that up here. So 8x squared plus 16x minus 42. And now we have to kind of, when we combine them, we have to remember to change the sign of everything on that right fraction, because this minus sign gets distributed to the whole thing. This is what would make everyone get it wrong, is they'd maybe be pretty good on this first half, but then they'd go to do the minus sign and they would only put the minus to the 8x squared. They would forget to put it to the 16x and the minus 42. So don't forget to do that. The minus, when it's in front of a fraction, it goes to the entire fraction. Okay, so let's write that now. So 15 minus 8x squared minus 16x plus 42. And I'm going to write this kind of in standard form, kind of like in the question. So negative 8x squared minus 16x. 15 plus 42 is 57. And that's looking pretty good. Before we go to determine our answer, what I suggest you do, just like with any equivalent expressions question, I go over this on my, with just x in it. I go over this in my Desmos videos. So what you can do is you can type in the original, 3 over 2x plus 7, tab, minus, and then I'm going to do the fraction sign before, because I got a messy thing on the top, 4x minus 6, tab 5. And now I'm going to type in what I came up with, and we're going to see if it is identical. So fraction sign, negative 8x squared minus 16x plus 57. X plus 35. Okay, and if I toggle this on and off, it certainly seems that what we came up with perfectly replaces the original. So it is an equivalent expression. So this is going to help us get the answer. Okay, great. Let's get rid of that and come back over here and we'll get the answer. So ax squared plus bx plus c. So a is negative 8, b is negative 16, and c is 57. So to find a plus b plus c, let's just call that the sum. Save some writing. We're going to do negative 8 plus negative 16 plus 57. And let me see what that is. Negative 8 plus negative 16 plus 57. That is 33, and that is the answer to this question. Okay, let's move on to the next one. Okay, everybody, so this is an experiments question. And this is really rare. So I wanted to include this because if it comes up on your test, you're probably going to have never seen it before, right? So it's kind of it's a good thing to review last minute. So experiments are different from observational studies like surveys. We actually do something, right? So like, let's say if I had 100 cancer patients and I gave 50 of them one medicine and then 50 of them the other medicine, that would be an experiment because we're actually doing something to the subjects. So essentially the concept that they want you to understand for this question is perfectly summed up that I have already pulled up with the magic of television in this table from College Board's official digital SAT study guide. It's the same one they use for the paper SAT as well. So you guys probably already pay close attention to when subjects are selected at random. That means it can be generalized to the population. I've talked about that in a bunch of videos. My statistics video, but my confidence interval and margin of error video, especially, I talked about that a bunch. how it needs to be selected at random for you to generalize. But something you don't talk about is this stuff over here. Okay, so the subjects in an experiment should also be randomly assigned to treatments, right? You can't just give like the men treatment A and the woman treatment B. What if the disease is somehow affected by if you're a man or a woman, right? So it needs to be randomly assigned. Ideally, if you have subgroups, 50% of each would go to each treatment. So that way you have a nice even blend. So it's kind of accounted for. Anyway, so you can see here, it says when you do random assignment, you can draw conclusions about cause and effect. And when you don't do random assignment, you cannot draw conclusions about cause and effect. So generalizing, random selection. Cause and effect, random assignment. So these guys right here, these words right here, randomly assigned, super important. Okay, let's go to the question. So it says, okay, the effectiveness of tooling test prep YouTube channel. Okay, a psychometrician selected 152 students for the study. Okay, the students were obtained from 2 randomly selected schools of 76 students each. Okay, so this isn't worded the best. I wrote this, but it sounds like everyone was selected at random, so we don't need to worry about that. And there are 152 students and then 76 students each from 2 schools. And this is really important. It says the students from one school received 1 treatment. They got the videos. And then the students from the second school did not use Kyle's videos. They were encouraged to seek other sources. So they got 2 separate treatments. One for the 76 students from each school. So this is no good. We did not do random assignment. Essentially, what if the differences in getting the videos, what if the students selected from the other school just happened to be a more advanced math students and it seemed like they did better? So definitely it can't be D, no changes to the experiment. That can't be right. All 152 students should receive access. How are you going to tell if the videos are doing anything if they all get it, right? And let's see. One of the schools should study without a calculator. That's just kind of off topic. That's just completely off topic. So that's wrong too. So you see it says half of the students from each school should be randomly assigned. So it's like even if you didn't 100% understand what was going on, they expect you to kind of recognize these buzzwords, randomly assigned. So it is answer C. So remember, guys, if you have subgroups in your sample, you want to make sure that if you're giving treatments, you give 50% each, right? Like if you had like for a cancer study, if you had like elderly patients, middle-aged patients, and young patients, something like that, you'd want to make sure 50% of each of those subgroups gets treatment A and 50% gets treatment B. That way, it's a nice kind of even blend. All right, let's move on to question 6. Okay, guys. So the next question expects us to know a little bit about end behavior. So I just pulled this up on from Google Images really quick to save myself some writing. We'll go back to the worksheet in a second. So like essentially what you need to understand is the lead coefficient, if you have an even degree like x squared, they're both going up if it's positive in front, and they're both going down if it's negative in front. You can kind of imagine like, x squared and negative x squared, right? And I'm actually going to, cite those as examples. What always confuses people, in my experience, is when they see an odd degree function and it kind of, it goes like slanted. So this would be like y equals x cubed positive. And this would be like y equals negative x cubed negative. So this always confused me for the longest time, but a really easy way to remember is, wait a minute, positive is kind of increasing as you go left to right. Positive, it's going up, right? And then decreasing is like, negative is like decreasing as you go from left to right. So hopefully that kind of makes sense. Anyway, so you definitely want to be able to quickly recognize, seeing just by looking at the ends, oh, which way is it pointing? And that will tell you the degree, if it's like an x squared, x cubed, x to the fourth, and it will tell you if it's positive lead coefficient or a negative lead coefficient. Let's go back to the worksheet. Okay, so right away I am noticing that this guy is kind of, it's, you know, doing a little disco, right? So this is an odd function. And because it's going down as we go left to right, it's got a negative lead coefficient. So let me jot that down. And let's look at the answer choices and let's see if that helps us narrow it down. Unfortunately, it doesn't. They all have negative 1/15 in front. So we don't really need to worry about that, which I guess is convenient, but maybe for a different question, it wouldn't be like that. Okay. Now, the next thing we need to know is the factor theorem. So this does not take that long to go over. The factor theorem basically says that if k is a root, then x minus k is a factor, and vice versa. So lots of people are really good at going from factors to roots, but people for some reason tend to struggle when they go from roots to factors. So all you do is you do x minus whatever the number is. So I'm going to make a little table of the roots, just a fancy word for x-intercepts. Then we'll write the factor, and then we'll write the power or multiplicity. So I'll just go from left to right. We've got an x-intercept at -1. We've got 4, and we've got 6. So let's write that down. -1, 4, and we got 6. Then we're going to do x minus the root, x minus. So x minus -1, that's just x plus 1. X minus 4, okay, that's just x minus 4. And then x minus 6, okay, that's just x minus 6. Now to figure out the powers, you look at the local behavior around the root. If it bounces, it's an even power. On the SAT, usually that's just 2, right? And if it crosses through, it is going to be an odd power. Usually on the SAT, it's going to be 1. So this one bounces. This one bounces as well. And then this one, as you can see, it goes through it, right? Goes through 4, so that one crosses. So if it bounces, it's probably going to have a power of 2. And if it crosses, it's probably going to have a power of 1. So we've got the lead coefficient followed by, so I'll just call it A, followed by x plus 1 squared, x minus 4, and then x minus 6 squared. Okay, let's see if there's any answer choices that look like that. And I believe B fits that bill. We got x minus 6 squared, x plus 1 squared, x minus 4, and we've got a negative lead coefficient. So B is the only one that checks off all the boxes. You can, of course, because this is multiple choice, type these all into Desmos and just see which one it is just by looking at it. I'm not going to do that in the interest of time. You can do that if you want. However, though, I encourage you to learn this, because what if there's a conceptual question with letters, or what if it's student-produced response? I could totally see this being reframed into being a student-produced response, in which case you don't have the answer choices to help you. So a bunch of things we just covered: end behavior, the factor theorem, so x minus k is x minus the root is the factor, and then the local behavior of the root. So if it bounces, it's even, in the SAT's case usually 2, and then if it crosses, it's odd, in the SAT's case usually 1. One last thing I want to highlight before we move on is people always seem to be confused by this. If the root is 0, the factor would be x minus 0. X minus 0 is just x, guys. So you'll see that often kind of in front. They'll just plop an x in front. That just means the root that goes with that guy is 0. Remember, x minus 0, it's just x. Subtracting by 0 doesn't do anything. Okay, let's move on to the next question. Okay, so hopefully I did this right. We need to take a... we need to make a picture of a right triangle, so let's do that. And we're going to do z is 90, so I'm going to make this guy z, and how about I make this guy x and y? And it says xz is 8. Okay, so let's put that. And it says the measure of angle y is 56. Okay, so let's put that. And which of the following represents the length? This is really important. Side YZ. So why don't we call him X? And I'm also going to circle this angle. You could go and find the other angle, but you'll see by looking at the answer choices and just in most standardized tests in general, they just want you to use the angle they gave you. So what we're going to do is we're going to first follow HOA to label the sides. Okay, HOA. So we're going to do the hypotenuse first. Across from the right angle is the hypotenuse. Across from the angle of interest is the opposite. And whatever's remaining is the adjacent. That is, people tend to struggle most with the adjacent, so I like to do that one last. Okay, so now we're going to look at SOHCAHTOA. SOHCAHTOA. And we're going to figure out by looking at everything that's labeled. So this, and this. What trig ratio we should use? Well, opposite and adjacent are labeled. So, opposite and adjacent are labeled. So we're going to use TOA, which is tangent. So we write tangent of 56 degrees is equal to 8 over x. Now when we get to this point, there's really two ways this is going to shake out every time when you're solving a missing side. So you could have the trig is equal to a number. I'll just use 5 for the example. How about x over 5? All you do is multiply both sides by 5. So that would be x equals 5 times whatever the trig is. But you could also have it like this. Trig equals 5 over x, in which case you would multiply both sides by x and then divide by the trig. A really quick mental way of thinking about that is you are just swapping those two. So x would be 5 over trig. So you just quickly swap them. So make sure you understand how to solve for x once you do that. So for this one, I'm going to use that algebra trick I just explained. Multiply by x, divide by tan 56, or just swap them. And we get x equals 8 over tan of 56 degrees. And it seems that is answer choice D, which I believe is the answer. And there's not really a whole lot you can do to check it. I just recommend that you understand SOHCAHTOA and how to solve that equation very thoroughly. You definitely want to make sure you circle the angle that you're focusing on, and then you want to label the sides. So opposite, hypotenuse, and adjacent. You should label those so that you can quickly figure out which trig ratio you need to use. For this one, we use tangent because we had opposite and adjacent labeled. You should come to my DSAT live stream. It's on Saturday, March 9th from noon to 3 p.m. Eastern Time. We're gonna play some games so that you don't have to keep thinking about this darn test all the time. You can ask me questions and vent about your test day concerns. You should check out Dylan Lee on YouTube in the pinned comment. He put a lot of time and effort into this musical graph. He would really appreciate a like on his video and a subscribe too.